So we've done about 3 hours of hard work on this subject, and it's time to let it rip a little bit and have a little bit of fun. I'm not going to go into any complicated maths or theory in this one. We're just going to have a look at a little Sunday afternoon project and see how we can tie diodes, op-amps and transistors together and make them do something useful. Well, in front of us here, what we've got is a very messy bench and a TRF system, and this TRF system fits in very well with what we've done in the last 3 videos because it's got a diode here, an op-amp here, and in this package, which is an LM386, there are in fact 22 transistors, plus about half a dozen resistors and a couple of capacitors. And what I hope this is going to do when I switch it on is act as a crystal radio. This whole thing is the detection, and this whole thing is the preamplification, and this is the output amplification. So we'll switch it on and see what happens. Well, I've got something already, and I'm not quite sure what it is. I think it's Radio 5 Live. Just so we can hear it a little bit better, I might put this glass over it. Yeah, it is Radio 5. Let's see if we can change the channel a little bit by doing this. And it's probably going to make a few horrible noises when I do it. And that's TalkSport, as it's just announced itself. It's not coming through very well. We could probably jiggle the aerial out a bit and get it a little better, but just for now. See if we can pick anything else up. We should be able to pick at least another one up. Now that is Absolute Radio by the sounds of it. And again, let's put the glass over it. Now, there are certain problems with this. It's a real junkyard thing. I made it with bits I found lying about in my junk box, just to illustrate the point about op-amps, diodes and transistors, really. It is a working project. It's a very nice project for a Sunday afternoon. So what we're going to do is we're going to look and see how it works, because radio really is the epitome of analog electronics, and let's see what we have. Now this receiver, of course, captures AM, amplitude modulation. Amplitude modulation has been around for years, at least 112 or so. And it's very, very, in this digital age, overlooked piece of technology, but it is still useful. Aircraft in particular, if a pilot wants to make a distress call, he'll do it on AM, because AM can let a weak signal break in, whereas FM would lock it out. And of course, digital signals are either there or not. So AM is still used in some certain circumstances, and it's used for broadcasting in the UK as well. And as we heard, we could get TalkSport, Radio 5 and Absolute Radio on this little set. So it's in 3 parts, and the parts are detection, preamplification and output amplification. And we'll have a look at the detection first and see what we've got. Now we zoom in. So what we have is we have a good old-fashioned tank circuit here, consisting of a variable capacitor and an inductor. And if I lived in this area, if I lived in an area with a strong signal, this ferrite loop stick would, in fact, work as both an aerial and an inductor. But I don't. So what I've got is I've got this red wire going off to another 10 feet of wire going around the room, which acts as an aerial. And from this orange wire, I've got another 10 feet going to ground. And of course, when you do that, that makes a dipole. But the thing of interest to us is here. This is a germanium diode, and germanium has a very low forward voltage drop. And what it can do is it can take the incoming wave and signal modulated onto that wave, and it can strip the signal out by a process known as envelope detection, and that's what it's doing here. So we'll zoom out again and we'll have a look at what else we've got. Here we have an op-amp, and you'll see I've configured it as an inverting op-amp, and the signal coming out of the germanium diode goes to the inverting, but it's configured in a way we've not seen before, in that I've put this resistor here to VCC, the supply voltage, just to give the resulting AC a kick. That'll give us a gain of somewhere around about 100, but the voltage coming out of the germanium diode is very, very small. Now these things usually are not made for loudspeakers like we saw there. They're usually made for earpieces, and if I did that, I could put high impedance earpieces on there. But high impedance earpieces are rare to find these days, and they're quite expensive as well. So what we want to do is we want to turn it into something we can use with a normal Walkman headset. Now again, and that's the output amplification. And the job here is done by an LM386 amplifier, which has 22 transistors, 6 resistors and a couple of capacitors, all in that package that you see there, which is smaller than my thumbnail. So there we go. A little bit of a fun project there to wind up on. Diode, op-amp, 22 transistors, all in a package. Job done.